we're going to look at comparing two means. We previously constructed a confidence interval and performed hypothesis tests for mu. For example, social scientists may claim that students who are members of a certain social media site have a mean GPA less than 3.1. To test this claim, we form a hypothesis, collect a sample of size n, calculate the test statistic, and then make our decision. So if we wanted to write the null and alternative hypothesis for this example, what he's claiming is that the members of the site have a mean GPA less than 3.1. So he's claiming the mean, so that's mu, GPA is less than 3.1. Okay, so when you form your hypotheses here, the null has the equals, so mu equals 3.1, and then the alternative, in this case happens to be what his claim is, that the mean GPA is less than 3.1. So the alternative is that mu is less than 3.1. Okay, so there's nothing new there. Now what we're going to look at is comparing two means for two distinct, independent groups of individuals. Suppose a social scientist claims that the mean GPA of students who use the social media site is less than the mean GPA of students who do not use the social media site. Okay, so here we're looking at two different means. We're looking at a mean GPA of students who use the site and then the mean GPA of those who do not use the site. Now those are two independent groups of individuals because there's no overlap between the two. They either use the site or they don't use the site. Okay, so those are two distinct independent groups of individuals. Now that's being taken from the population of all students, but now you're separating them into the two groups. Okay, so if we wanted to write the null and alternative hypothesis for this example, well now what he's claiming is that the mean for those who use the site is less than the mean for those who do not use the site. So now we're not trying to claim that a mean is less than a certain GPA. We're just trying to say that one mean is less than another mean. So this is comparing two means. Okay, so your hypotheses here, your null hypothesis, again, always has the equal sign. So the mean of the users equals the mean of the non-users. Okay, so mu sub the users equals mu sub non-users. And then the claim was that the mean of the users is less than the mean of the non-users. Now I want to point out that another way to write those hypotheses is comparing them to 0, which is basically subtracting the mean of the non-users from each side. And then the null hypothesis would be that the difference in those means equals 0, and that's just saying that the means are the same. Okay, the mean for the first group equals the mean for the second group. And then the other one, if you subtract the mean of the non-users, you would get the mean of the users minus the mean of the non-users is less than 0. Okay, so that's just another way to write those two hypotheses. Okay, so now if we want to test this claim, we need to take a sample of students from each population. One sample will be from the population of students who use the site, while the other sample will be from the population of students who do not use the site. Okay, so now the big huge population is all students. Now we're looking at a population because we have them separated into two groups. So there's a population of students who use the site and a population who do not use the site. And we're going to take a sample out of each of those populations. Okay, so let's just suppose we did that. We can calculate the sample statistics from each sample. Okay, so x bar sub 1 will be the sample mean of the users, x bar sub 2, the sample mean of the non-users. And then each of those samples also has a standard deviation that goes with it. Okay, the subscripts just tell you which group you're dealing with. So we can define the users to be the first group and the non-users being the second group. Okay, so the sample sizes, N1 and N2, of each sample do not need to be the same. However, the samples must be independent and two simple random samples from two distinct populations, which is what we have here. Both populations must be approximately normal, or N1 and N2 must be large enough. Okay, so being approximately normal and N1 and N2 large enough, that goes back to the central limit theorem. Okay, so here are the formulas for your test statistic and your confidence interval when you are comparing two sample means. Okay, so it's a t we use the t generally because we're taking a sample of size n. We don't have the population of standard deviation sigma, so we're not using z. You can be given z, but t is the more realistic one, so this is what we focus on here. Okay, so essentially what you do, you take the difference in the sample means minus the difference in the population means, and then divide it by the first standard deviation squared over the first sample size plus the second standard deviation squared over the second sample size. You take the square root of that. Now I know you look at that and you say, well, gee, that looks really confusing. But remember that the t-test statistic for one sample, so if we were doing the hypothesis test for the first one up here, okay, so one sample t, remember that formula was t equals x bar minus mu. So if you covered up the second x bar, so x bar and then minus mu, that's the same thing as this. And then in the denominator, we had divided by s over the square root of n. Well, when you take the square root of s squared over n like that, you take the square root of the numerator and denominator. So you look at the square root of s squared as being s, and then square root of n like that. Okay, so you can see when you square root s squared over n, it's essentially the same thing as this. Now mathematically, because we're bringing in that second sample, you can't just take the square root of each of these. You have to leave that all as one square root. Okay, but the point is it's the same concept. It's just that we have two samples now. Okay, and then the confidence interval for the difference in means. So before, what we had for one sample was we took our sample mean and then we added or subtracted our t star times s over the square root of n. Well, now, because we have two means, we have to subtract those means, find the difference in the sample means, and then you add or subtract your t star, same as before. And now, instead of one sample, we have two. Okay, so again, it's really the same idea, except it just looks a lot more confusing.